In the final weeks of 2022, the world watched a spectacle of creation. A river of fire carving a new path across the largest active volcano on Earth. For the first time in 38 years, Mauna Loa was awake. And it was breathtaking. It was also a lie. Not the eruption itself. That was terrifyingly real. The lie was the feeling it left behind. A feeling of relief. Of a danger met and managed. A sense that the gentle giant had stirred, put on a magnificent show, and gone back to sleep. That was the lie. Because the volcano is not sleeping. It is reloading. And the next time it fires, it will not be a show. It will be a catastrophe. Before we go any further, I want to know what you think. Based on what you've seen so far, do you believe the danger has passed? Or is it just beginning? Drop your comment below. Let's start the conversation. Today, new data from inside the volcano reveals a fundamental shift, a change in pressure, deep underground, that is aiming the world's biggest volcano at thousands of homes built directly in its most dangerous path. The next eruption will not be like the last one. It will not move slowly. It will not take weeks to threaten a highway. It will move in hours. A huge number of people who watch our documentaries aren't subscribed. If you find value in this kind of deep dive, hitting that subscribe button is the single most important way to support what we do. It's an emergency button for our channel's survival, and it ensures you won't miss what's coming next. It takes 1 second. Click it now so you don't forget. Okay, let's begin. Mauna Loa was never supposed to be safe. It covers 51% of the island of Hawaii, a landmass so enormous it physically warps the Earth's crust beneath it. Its summit rises 13,681 feet into the thin Pacific air. By every geologic metric, it exists in a state of perpetual, violent rebirth. It is in its shield-building stage, the most active phase of a volcano's life. And for most of its recorded history, it erupted like clockwork. Not every 38 years, every 3 to 4. Then came the Great Quiet. From 1984 to 2022, the volcano went dormant. An entire generation grew up on its flanks, knowing it only as a colossal, silent mountain. A backdrop. A postcard. That silence allowed for a dangerous assumption to take root. The assumption that the volcano's violent youth was over. That the quiet was the new normal. It was not the new normal. It was an anomaly. A pause. A breath before the storm. On November 27, 2022, at 11:30 p.m. local time, the pause ended. Deep within the summit caldera, a 3-mile-long basin of shattered rock named Mokuweoweo, the ground split open. Magma that had been quietly pooling for decades finally broke through. The eruption had begun. For the scientists at the Hawaiian Volcano Observatory, this was the moment they had trained for their entire careers. The question was not if Mauna Loa would erupt. It was where the lava would go. Mauna Loa operates on a rigid playbook. Nearly all of its 34 recorded eruptions since 1843 have started inside Mokuweoweo. But the summit is just the staging ground. Within hours or days, the immense pressure of the rising magma seeks an exit, cracking the caldera walls and forcing the eruption down one of 2 main pathways. 2 geological superhighways of fractured rock, the Northeast Rift Zone, or the Southwest Rift Zone. On November 28, 2022, the mountain made its choice. The magma broke free and began migrating down the Northeast Rift Zone, or NERS. A collective sigh of relief echoed across the island. The NERS is the safer option. Its slopes are gentler, its path more predictable. The target was not a town. It was a highway. The Daniel K. Inouye Highway, known locally as Saddle Road, is the critical artery connecting the east and west sides of the island. For 15 days, the world watched as a tongue of lava crept slowly, deliberately toward that ribbon of asphalt. Dr. Ken Hahn, the scientist in charge at HVO, became the face of the response, delivering calm, precise updates. His team used drones, helicopters, and ground mapping to track the flow's every move. The lava was thick, viscous, moving like a wall of cooling rock 20 feet high. It was powerful, unstoppable, but it was not fast. It gave people time. Time to plan, time to prepare, time to watch from a safe distance as the Earth remade itself. On December 13, the eruption ended. The lava stopped just under 2 miles from the highway. The danger had passed. This is the event the world remembers. The slow, creeping flow. The manageable crisis. The spectacular light show that ultimately threatened infrastructure, not lives. And it has created a deeply misleading sense of security. Because the other side of the mountain is not gentle. It is not slow. And it is where the volcano is aiming next. I'm seeing some incredible insights in the comments already. For those who haven't weighed in, here's a new question for you. Knowing the difference between the two rift zones, where would you have built a home on the island? Let me know below. The Southwest Rift Zone, the SUR, is a completely different animal. Geologically, it is the mountain's weak spot, a zone of weakness that plunges from the summit toward the sea at an incredibly steep grade. While eruptions on the Northeast Rift Zone produce sluggish, thick flows that build upon themselves, eruptions on the SURs produce rivers of fast-moving, fluid lava. Lava that does not creep. It races. There is a historical precedent for this. A blueprint for exactly what happens when Mauna Loa chooses the southern path. It is not a model or a theory. It is a memory, burned into the landscape in the history books. It is the eruption of 1950. On June 1st, 1950, after a brief summit phase, just like in 2022, Mauna Loa cracked its southwestern flank. A 13-mile-long series of fissures opened up, unleashing a catastrophic volume of lava. From a vent at 11,000 feet of elevation, a river of molten rock began pouring down the steep mountainside. It was not moving at feet per hour. It was moving at miles per hour. The front of the main flow was clocked at an average speed of nearly 6 miles per hour. An agonizingly fast jog. Unforgettable, unstoppable, it crossed the main highway in less than 2 hours. And in just 3 hours, it had traveled 15 miles from the fissure to the coast, where it poured into the Pacific Ocean in a violent explosion of steam and shattered rock. 3 hours. From the quiet of the upper mountain slope to the boiling sea, entire villages in its path had no time to evacuate anything but their lives. The historic coastal settlements of Ho'okina and Fiho, places that had existed for generations, were overrun, destroyed, wiped from the map. The sheer power was biblical. When the lava hit the ocean, the steam clouds it generated rose 10,000 feet into the air. The water boiled so violently that thousands of dead, cooked fish washed ashore for days. The glow from the lava fountains and the incandescent river of fire was so bright, it was clearly visible from the island of Oahu, over 200 miles away. This was not a spectacle, it was a rampage. During the chaos, a local ranch hand was trapped between two of the fast-moving lava rivers. He was stranded on a small island of untouched land for 28 hours, watching fire race past on both sides, before the U.S. Coast Guard could stage a desperate helicopter rescue. The 1950 eruption showed the world Mauna Loa's other face. Not a gentle giant, but an unforgiving force of nature operating on a timeline of hours, not days. And this is the eruption that the new data suggests is coming. If you're finding this story as gripping as I am, take a moment to hit the like button. It tells the algorithm this is a story that matters. And if you have family or friends fascinated by the power of our planet, share this video with them. It's a story everyone should understand. After the 2022 eruption ended, Mauna Loa entered a period of deflation. The mountain sagged, like a tire letting out air, as the pressure from its internal magma chambers was released. This is normal. Expected. What wasn't expected was how quickly it would start to reinflate. By late 2025, scientists at the Hawaiian Volcano Observatory noticed something had changed. The volcano had stopped sagging and started to swell again. Slowly, millimeter by millimeter, the ground surface was being pushed upward and outward. Magma was once again refilling the reservoir system deep beneath the summit. This is confirmed by two key streams of data: an increase in shallow earthquakes and ground deformation measured by hypersensitive GPS stations. In April of 2026, scientists recorded 132 shallow-depth earthquakes under the summit. By May, that number had jumped to 170. These are not quakes a person could feel. They are the sound of rock shifting, cracking, and making way for new magma accumulating below. The volcano is waking up. Again, but here is the critical piece of information, the part that changes everything. It is not just that the volcano is reinflating. It is where it is reinflating. Dr. Ingrid A. Johansson, a research geophysicist at HVO, specializes in interpreting this ground deformation. Her job is to turn those millimeter shifts into a coherent picture of what is happening miles underground. What her data showed in early 2026 was unambiguous. A USGS notice from January stated it plainly: the center of deformation has shifted to the southern caldera region. This is not an academic detail. This is the entire story. Think of the volcano's plumbing like a complex hydraulic system. During the buildup to the 2022 eruption, the pressure was concentrated in the northern part of the summit magma chamber. When it burst, it took the path of least resistance, north now. That same pressure is building in a different place. The magma is actively pooling in the southern part of the caldera. It is loading a different chamber. It is physically aiming the volcano's force not toward the gentle slopes of the NERs, but toward the steep, treacherous fault lines of the SURs. The gun is being reloaded, and it is pointing in a new direction. This isn't just a guess based on ground-level GPS. We can now see the mountains stretching from space. Researchers Falk Amalung and Bhuvan Varugu at the University of Miami use a technology called INSAR, or Interferometric Synthetic Aperture Radar. Satellites bounce radar signals off the volcano's surface, measuring the distance down to the fraction of an inch. By comparing images over time, they can create a map of the volcano's breathing. They can see which parts are swelling and which are not. A year before the 2022 eruption, Amalung and Varugu published a study showing that the inflation on Mauna Loa was biased to the north. They correctly predicted that when the eruption came, it would follow the northeast rift zone. They were right. Today, their same technology, watching the same volcano, is showing the maximum strain building on the southern flank. The same telltale stretching that preceded the 2022 eruption is happening again, but this time, it is pointing south, aiming directly at the path of the 1950 disaster. This changes the entire risk equation for the island. The 38-year quiet period from 1984 to 2022 created a false sense of security. It wasn't just a psychological lull. It was a development boom. During that time, thousands of people built lives on the flanks of Mauna Loa, many in subdivisions plotted out directly on top of old lava flows. Nowhere is this more true than on the volcano's southern flank. The community of Hawaiian Ocean View Estates, often just called Ocean View, is a massive residential subdivision. It is one of the largest in the United States, and it is built almost entirely on the steep, vulnerable slopes of the southwest rift zone. Its existence is a testament to the belief that the volcano's most destructive behavior was a thing of the distant past. The work of legendary USGS geologist Frank Trustle, who spent over 2 decades mapping Mauna Loa's historical flows, tells a different story. His lava inundation maps, the official hazard charts used by emergency planners, show Ocean View sitting squarely in harm's way. The flows from 1950 bracketed the area. Other flows, from centuries past, run directly through it. The residents of Ocean View are not living near a volcano. They are living on it, on its most dangerous side. The side that is currently showing every sign of preparing for its next eruption. The 2022 NERS eruption gave island residents days of warning as the lava slowly approached Saddle Road. days to make decisions. And Stir's eruption, following the 1950 playbook, could cover that same distance in a few hours. What does an evacuation order look like when you have 3 hours to move an entire community? When the only roads out might be the first things the lava cuts off? This is the question that now haunts the Hawaii Emergency Management Agency, or HIEMA. They plan for worst-case scenarios, and the data from Mauna Loa is showing them that the worst-case scenario is no longer a distant possibility. It is the most probable one. The disconnect between public perception and scientific reality is stark. The world saw a beautiful, slow eruption in 2022. It looked manageable, photogenic, many people living on the island, and especially those who have moved there since 1984, have never experienced anything else. They have no living memory of the 1950 event. No intuitive understanding of how fast that mountain can move when it breaks south. The threat is not abstract. It is a physics problem. Steep slope plus fluid lava equals terrifying speed. The science is not ambiguous. The inflation is real. The southern shift is measured. The historical precedent is undeniable. The only thing scientists cannot give is a date. No one can say when the pressure building beneath Mokuowo will reach its breaking point. It could be next year. It could be next month. It could be tomorrow. But what they can say, with a growing and uncomfortable degree of certainty, is where it will go when it does. All right, I'm going to say it again, because the numbers don't lie. Most of you are still watching unsubscribed. I get it, you're engrossed in the story. So I'll make it quick. If you're learning something new right now, please take a second to subscribe. It makes a world of difference. Thank you. Now back to the volcano. The historical context is what makes the current situation so concerning. Before 1950, Mauna Loa was one of the most reliably active volcanoes in the world. Eruptions were frequent, a regular part of life on the island. The 38-year quiet period was the longest documented break in eruptive activity in at least 2 centuries. It was a statistical outlier, a geological anomaly. The 2022 eruption signaled the end of that anomaly. The volcano is active again. The question is whether it is returning to its old, more frequent eruption pattern. If it is, the reinflation we are seeing now is not just a geological curiosity. It is the first step in the next cycle. The refilling of the chamber in preparation for the next eruption. An eruption that the data strongly suggests will be a fast, destructive SERPs event. The quiet lull lulled people into a state of complacency, allowing developments like Ocean View to sprawl across zones that were historically known to be hazardous. They were built on a bet that the volcano's long slumber was permanent, a bet that now looks increasingly like it was wrong. The work of the Hawaiian Volcano Observatory is a race against time. Their network of seismometers, tiltmeters, GPS receivers, and gas sensors is one of the most sophisticated volcano monitoring systems on the planet. It is designed to give the earliest possible warning. When an eruption begins, they will know within minutes. They will be able to pinpoint the location of the outbreak, whether it remains at the summit or migrates down a rift zone. But even with that advanced warning, the physics of the swirls remain terrifyingly simple. Once lava breaks out on those steep slopes, the response time for communities in the path is brutally short. HIEMA and local authorities have emergency plans. They conduct community meetings. They urge residents to have a go bag and a plan. But planning for a disaster and living through one are two vastly different things. The 1950 eruption serves as a chilling reminder that even with the best intentions, a lava flow moving at the speed of a running person can outpace any human response. It is a tale of 2 volcanoes contained within one mountain. The northern flank, which erupted in 2022, is like a slow-moving giant. Its power immense, but its advance ponderous, giving days to react. The southern flank, where pressure is now building, is a sprinter, a force of pure speed, capable of wiping out everything in its path before an effective warning can even be fully disseminated. The challenge is communicating this dual personality. The recent, globally televised memory is of the slow giant. The urgent, scientific reality is of the sprinter, now coiled at the starting blocks. This is not a misunderstanding of intent, but of capability. The volcano itself hasn't changed. Our understanding of its immediate intentions has. Okay, last time I promise. Well, maybe. It's just that important. We put hundreds of hours into this research, and all we ask in return is that one little click. If you've made it this far, you're clearly one of us. Hit subscribe and make it official. Now, let's bring this story home. The 2022 eruption was a vital lesson. As Ingrid Johansson of the HVO put it, it was the first Mauna Loa eruption that occurred during the current era of modern instrumentation. It allowed scientists to test their models and their monitoring networks against a live event, gathering a treasure trove of data. That data helped them calibrate their understanding of the volcano's plumbing, and it is that same calibrated understanding that now makes the southern inflation data so alarming. They are not just seeing a signal. They are seeing a signal they now know how to read, and it is telling them to look south. The real question is no longer if Mauna Loa will erupt again. That is a certainty. The real question is whether the lessons of 1950 can be learned and acted upon before the mountain repeats its own history. Did the 38-year quiet period just delay the inevitable, allowing a new generation to build a life in the path of a disaster they couldn't imagine? Or can the science of today, the satellites measuring the stretch of the ground, the GPS receivers tracking the swelling of magma, give people the one thing the 1950 eruption did not? A chance. The fate of communities like Hawaiian Ocean View Estates hangs on that question. They are living on the knife's edge of a geological certainty. The evidence is not in a history book. It is being written right now in the form of millimeter-scale ground movements and faint subterranean tremors. The volcano is speaking. The scientists are translating. But the message is one of profound urgency. The 2022 eruption was a warning shot. It proved the long nap was over. It reminded the world what Mauna Loa is capable of. But it did so in the gentlest way possible. Now the seismic data, the ground deformation, the lessons from space, all point to a far more dangerous conclusion. The giant is awake. It is reloading. And this time, it is not pointing at an empty road. It is pointing at people's homes with a speed and fury that the modern world has never had to confront from this volcano.